All right, this section of your notes is going to talk about different weather properties. It's going to go into clouds, fronts, air masses, and severe weather. So the objective of this set of notes is that you guys are going to be able to describe the different weather properties of fronts, of the different air masses, pressure systems, clouds, and all severe weather. The 5 things we're going to focus on: clouds, air masses, pressure systems, fronts, and storms, all are equally important, and this is going to take a while, so bear with me. As far as weather goes, a couple of basics that you guys already know because we've talked about a lot is humidity, which is the amount of water vapor in the air. So you know that relative humidity is just that represented as a percentage. So it's the percentage of water vapor that's actually in the air versus the maximum amount that the air can actually hold. And something new for you guys is that when we use the tool to measure water vapor and humidity, we use what's called a psychrometer. So the next section goes into clouds and how clouds form. And water vapor is essential into understanding the formation of clouds. So clouds form whenever that water vapor, which was a gas, condenses down to form water or ice. We talked about in our last set of notes how the dew point was that temperature where condensation actually starts to occur. So in order for that condensation to occur, we also have to have particles in the air. No air is pure. We have liquid particles, solid particles, all kinds of particles in our air. So what happens is the water vapor looks for particles to condense on, and then it starts to form clouds, and the air has to be cool as well. If it's not cool, then that's going to stay a gas and it's not going to start to condense and form a cloud. And also from our last section of the notes, you guys should remember that warm air holds more water vapor than cold air does. So let's talk about the different types of clouds. The first type of cloud we have is a cirrus cloud. Cirrus clouds are your very high level clouds, so they're the highest up in the atmosphere. They are thin, wispy clouds, and because they're so high up in the atmosphere, we know that as we go up in the troposphere, it gets colder. So if cirrus clouds are at the top of our troposphere, they're our highest level cloud, then these clouds are going to be in the coldest section of the atmosphere, which means they are going to be composed of ice crystals, okay, because it's so cold at that level where they are made. They are the highest level cloud, and a good way to remember cirrus clouds is that they are nice and curly and wispy. Okay, any type of cloud that's wispy like that, very light and wispy looking, that's going to be a cirrus cloud. The next type of cloud is the cumulus cloud, which all of you guys should be familiar with. This is like the typical cloud that we see most days. Cumulus clouds are considered low-level clouds, so they're not high-level clouds like the cirrus clouds, and they're what we usually call the cotton ball-looking clouds, so they are white and puffy. Most of the time, cumulus clouds are associated with neutral or fair weather. Okay, it doesn't mean a big storm's coming. It doesn't mean it's going to rain for days. It just typically means we're going to have decent weather. So next is the stratus clouds, and these clouds just kind of blanket on the sky. You can see how it just looks like one big blanket across the picture here. These clouds are also low-level clouds, like the cumulus clouds, and they cover the entire sky and typically mean that there's going to be rain coming with them. The word nimbus can kind of go along with any of the cloud names, so you can have cumulonimbus clouds, and nimbus just means rain producing. So if that word nimbus is thrown on to any other cloud name, nimbo, nimbus, whatever, that means that that particular cloud is going to be bringing rain. And these are clouds that usually appear with that gray color or that getting darker color that you see whenever rain is produced. The prefix alto stands for high in the sky. So if someone throws the word alto in front of a cloud, like alto cumulus or alto stratus, that's going to be a higher level cumulus cloud or a higher level stratus cloud. So if you think about where a cumulus cloud would normally be, an alto cumulus cloud would be up just a little bit higher. Same thing with alto stratus. Think about where a stratus cloud would be. An alto stratus would be up just a little bit higher than a regular stratus cloud. Here's a general picture that shows you the basic cloud classifications. A very important cloud for you to know is this one right here, the cumulonimbus cloud. You know that cumulo or cumulus clouds are like the puffy fair weather clouds, but when you throw that nimbus word on there, that means it's going to be producing rain. So whenever those clouds build up and build up and build up, they're called cumulonimbus clouds, and those are our thunderstorm clouds. They're going to bring our bad weather. Also in this picture, you see fog, which is considered a cloud, and it's at ground level. You see how the cumulus cloud is low level, the stratus cloud is low level. And then up at the very top, we see our cirrus clouds. Okay, these are our high level clouds that are composed of ice crystals because they're up so high in the atmosphere. Now we're going to talk about the different air masses and fronts and the pressure systems. An air mass is defined as a huge body of air, and this body of air is going to have similar temperatures throughout it, similar humidities, and similar air pressure throughout the whole air mass. And there's 4 main types that we talk about. We talk about polar, tropical, maritime, and continental air masses. You guys know by now that polar means cold, tropical means warm. That's easy. The 2 words you might have a hard time with are maritime and continental. Continental, think of the continent, and the continent is on land. If you have a continental air mass, it's one that forms over land and it's going to be dry. Maritime, I want you guys thinking of like ocean, and whenever an air mass forms over top of the ocean, it's going to be moist and it's going to pick up a lot of moisture. Okay, so polar air masses are cold, tropical air masses are warm, maritime air masses are going to be moist and form over the ocean, and I'll write that in for you really quick. And then the continental air masses are dry because they form over land, so they don't have any water to pick up to make them moist. This is a picture of a maritime polar air mass, and you can see that maritime means that it's going to be forming by the ocean, on the ocean here, okay? So it's going to be a moist air mass, and it's polar because it's forming up here in our colder regions. Okay, so a maritime polar air mass is going to be a moist air mass forming over water, and it's going to be from a colder area. The next one is maritime tropical. Tropical means it's going to be warm. It's going to bring warm weather. And maritime, once again, means it's forming in the ocean. So you see here, the air masses are down here in the ocean, but now they're more so near the equator. Okay, so they're going to be bringing, or that air mass is going to have more of a warmer temperature. The next one is continental polar. Polar, once again, meaning that it's going to be a cold air mass coming from up north. And continental, meaning it's forming over the land. Okay, it's not picking up moisture from any body of water. It's going to be a continental air mass, meaning it's dry and it's forming over land. The last type is continental tropical, and continental, once again, forming over the continent or land. See, not over the water. And tropical, meaning it's more near the equator here. So it's going to be a warmer air mass. And this picture shows you a general idea of where the different air masses are coming from. All your tropical air masses are coming from your warm areas. All of your polar air masses are up near the poles, where it's cooler. All your maritime air masses, like these ones, are forming in the ocean. So they're coming from a body of water. They'll be moist. And then the other alternative here is our continental air masses, which you see forming over land. So these are our dry air masses. Once we've talked about air masses, we can kind of move on to fronts and the different type of fronts that there are. A front occurs whenever you have 2 unlike air masses that meet up. So when these 2 unlike air masses meet up, it forms a boundary, and that boundary is the front. So there's 4 types of fronts. We're going to cover cold fronts, warm fronts, stationary fronts, and occluded fronts. And as I describe them, I'll show you what their symbol would look like on a weather map. The first type of front is a cold front. So a cold front is the leading edge of a cold air mass that's going to push your warm air mass up. Okay, so your cold front, it's coming in, it's going to push that warm air mass up above it, and cold fronts move really quickly. Okay, they're the quickest moving front. So because of this abrupt and quick movement, they are going to cause fast weather changes. Okay, the amount of rainfall, or if rainfall occurs at a cold front, depends on the warm air mass ahead of it and the water vapor that's in that front. If the warm air mass above it has very little water vapor, it's not going to, create a bunch of precipitation. However, if the warm air mass was holding a lot of water vapor, then yes, you will see rain with a cold front. A warm front is the leading edge of a warm air mass. So in this situation, we have our warm air mass that's advancing. It's going up, okay, and it's going to be moving slowly. So these are our more slower fronts. So cold front was really quick. Warm fronts come in very slowly. So what happens is that advancing warm air is going to move the cold air out of the way. And whenever we have a warm front, it can be cloudy or rainy for several days. After that warm front passes through, though, we're going to have, of course, warm and humid weather. The next type of front is a stationary front. And a stationary front is whenever you have your cold air mass and you have your warm air mass, and they meet, but they're in a standoff. One can't push the other one out of the way. One's not going to go up or under the other one. They're just going to kind of be at odds. They're in a standoff. Whenever this happens, there's going to be precipitation. So at this boundary right here, you're going to see precipitation. And if the stationary front stays a stationary front for a long period of time, then that precipitation stays for a long period of time as well. Okay, so depending on how long it takes one air mass to finally overcome another one, that's going to determine how long the rain is going to stay. The occluded front is the last front, and this is your most complex front, and it's the most complex one because here you have 1, 2, 3 different air masses involved, okay? So your first two air masses right here and right here, both of these are going to be cold air masses, all right? What they're going to do is the two cold air masses are going to meet and cut off the warm air mass up here, okay? And when it cuts off that warm air mass, it lifts it up so it never even touches the ground. Whenever this type of front occurs, there's going to be cloud formations and possibly precipitation depending on the amount of water vapor that the warm front is, or that the warm air mass is holding. So talking about cyclones, there are such things as cyclones and anticyclones. We talked about cyclones a little bit when we talked about hurricanes, and you know that hurricanes and all bad weather typically forms with our low pressure systems, all right? So cyclones are areas of low pressure, and what it is it has a center, and that center is swirling counterclockwise, so this direction. And so it's swirling counterclockwise, and it's the center of low pressure. Whenever we have cyclones, or whenever this situation occurs, you're definitely going to have your clouds, your winds, and your precipitation, okay? And these do form at frontal boundaries. Anticyclones are the opposite, okay? They're going to form with high pressure. So if our cyclones form with low pressure, and this is going to bring bad weather, then our anticyclones are going to be the opposite, and they're going to form at high pressure. With anticyclones, it's a high pressure center of dry air, and these are going to do the opposite, and instead of doing counterclockwise, they're going to rotate clockwise, okay? And it's just going to bring dry and clear weather, and these also form at frontal boundaries. This is just a picture showing what we just talked about. Here's your high pressure system, the first part, bringing us nice, calm, clear weather. Okay, our cold air is sinking. And then we have our low pressure cyclone over here, where your winds are converging and our hot air is rising and it's forming storms and cloudy weather. A way to remember it is if you're low, you're having a bad day. So low pressure brings bad weather. So let's talk about all the different types of bad weather that there are. The first type we're going to cover is floods. So floods is whenever a flood occurs whenever we have a lot of rain. Okay, so the volume of water is going to be increasing in a short period of time. The soil is not going to be able to hold any more of the water, which is going to cause a bunch of standing water. It's going to cause bodies of water to overflow, dams to break, okay? And there is such thing as a flash flood as well. And think of something happening in a flash. It happens very quick. So a flash flood is something that's going to be happening quickly. So if a bunch of rain falls in a very short amount of time, that's a flash flood. Advanced warnings are beneficial. We have created dams and levees. All of these are safety measures and forms of flood control to help us deal with these types of situations when floods occur. The opposite of a flood is a drought. So a drought is whenever you go a long period of time with very little rainfall, okay? This is when you see your ponds drying up, your channels, your rivers, all those things. Whenever they're losing their water and they're drying up, this is because of a drought. So it's typically caused by dry weather systems that remain in place for long periods of time and that aren't releasing much precipitation at all. Whenever we have droughts, we have to be really careful to conserve our water. Because obviously there's a shortage of it. Thunderstorms or electrical storms, these are going to be your storms that are forming in those cumulonimbus clouds that we were talking about earlier. They're brief, they're really intense, and they occur over small local areas. These occur whenever warm air is forced really rapidly upwards along a cold front, and it forms the cloud that we like to call a thunderhead, and that's what's going to produce the thunderstorm. So some characteristics of a thunderstorm is that it can bring possible hail and heavy rains. You're going to have strong upward and downward winds, which are called updrafts and downdrafts, and it's also going to bring the typical lightning and thunder. Tornadoes also develop in those cumulonimbus clouds, and they start to form a funnel going down, just like you see in this picture here. It looks like a big funnel going down from the sky. Tornadoes form whenever you have a warm, humid air mass meeting a dry, cold air mass. So two completely different air masses colliding. The warm air is going to be forced upwards, okay, along that cold front, and it produces several thunderstorms, which can turn into tornadoes. This is the most damaging type of storm because tornadoes aren't as predictable as the other types of storms are. And a characteristic of tornadoes is the spiraling winds that occur, the deep area of low pressure. All of these things are characteristics of a tornado. There is an area of the United States that we call Tornado Alley because they see tons of tornadoes, and this is from the central United States, from Texas, kind of towards the Nebraska-Iowa area, and they see nearly 800 tornadoes. It's ridiculous. Next is hurricanes. Hurricanes, which we have been experiencing lately, are our big, massive systems, and they have really strong winds over 119 kilometers per hour. They're very large storms, so they can be about 600 kilometers across. They form in our oceans, so in the Atlantic, Pacific, or Indian Oceans, because they need warm water, so those oceans are suitable to create hurricanes. The strength and the energy that the hurricane has is going to come from the warm, moist air. Okay? It also has to have that warm ocean water. And it forms on a low pressure area. Remember that low pressure brings bad weather. So hurricanes are these huge rotating storms that are going to be forming around low pressure areas. We know from experience that hurricanes can bring damaging winds. Excuse me. That they bring lots of rain, and as far as coastal areas go, they can bring in large waves that's going to cause flooding. Winter storms are our storms that are going to bring the ice, the sleet, and the snow. These are associated with our cold fronts, especially quickly moving cold fronts. We know our cold fronts are the quickest moving front that there is, so whenever we have those quickly moving cold fronts, winter storms can occur. Winter storms produce high winds. We know that they have low temperatures, obviously, and they can cause accumulation, which means that there can be ice or snow or whatever it is accumulating on trees and on power lines. And when that happens, we're going to have power outages. Trees are going to fall down on the roads. We're going to have accidents. Cars aren't going to get traction on the roads. And then, of course, we love to close our schools and all our businesses whenever we have some winter storms. So you're going to see some closings whenever this happens. The last part of severe weather is just basic precipitation. So all year round in all areas of the world, almost all precipitation begins from our clouds, starts as snow, because of course it's cold up in the troposphere, and then it melts as it's coming down into the atmosphere as it reaches those warmer temperatures. Now, precipitation will remain as snow if our air temperature is colder than 0 degrees Celsius, which in our conversions is 32 degrees Fahrenheit. Okay, so that precipitation coming down will stay in the form of snow if our air temperature is cold enough. The 4 basic types of precipitation that you need to know are rain, snow, sleet, and hail. All right. That is all I have for you guys. However, I do want to talk about some of the symbols really quick for the warm fronts, cold fronts, stationary fronts, and occluded fronts. So on the next slide, I'm going to go over some of those symbols. All right, so the different symbols we see. If we have a front with curves like this, that I like to say look like little sunshines, okay, that represents a warm front. If you have one like this with triangles, I say that the triangles look like icicles, so that represents a cold front. A stationary front is whenever you have one cold front and one cold air mass and a warm air mass pinned against each other. So you'll have cold on one side, warm on the other. Cold on one side, warm on the other. Okay? And that's stationary. And the last one is occluded, and that's when you have a warm caught in between two cold. So cold, warm, cold, which shows you your warm front caught in the middle. All right, if you guys have any questions, we'll talk about more of this information in class.